Day 8, solving inequalities, applying properties of inequality. Learning targets. Today I will apply the properties to solve multi-step inequalities so that I can represent solutions in set builder notation. FCPS portrait of a graduate includes communicator, collaborator, ethical and global citizen, creative and critical thinker, goal-directed, and resilient individual. So we have 5 different possible ways we can set up inequalities. They can be represented in word form. In this case, x is greater than 3. Algebraically, x greater than symbol 3. Graphically, you have your number line. Open circle around positive 3. Arrow going to the right. Interval notation. You have either parentheses or brackets. We can talk about when you use parentheses or brackets. In this case, since it's open circle, we use parentheses, and it's from 3 to positive infinity, because remember the arrow, your line can go on forever and ever. And the other new part, the set builder notation. So here we have braces that's surround our set builder, and then you always start with your variable. So in this case, the x, you have an up and down line, which is represented the words such that, and then you have your algebraic inequality, which is seen from above. In this part of our notes, whenever we have an open circle, that's when we will use the round parts of our round parentheses for intervals. And notice how when the arrow goes to the left, you start with either, well, you would always start with a parentheses, negative infinity, because again, in both open and closed circles, arrow to the left goes on forever and ever. And we'll never get to negative infinity. So that's why we use the parentheses. We'll never touch negative infinity. But nonetheless, for less than or equal, we always draw our line to our left. And for set notation, which is set note for our interval notation, I'm sorry, you always start with, if your arrow goes to the left, negative infinity with an open parentheses. Now, if it was, in this case, with less than 3, you close round parentheses and you start with positive 3. If it was less than or equal, which includes the 3, then we use our bracket. That's the difference between when it's closed versus when it's open and closed. So closed, bracket. Open, we use parentheses. Similarly, let's say if our arrow goes to the right forever and ever, then for the interval notation, positive infinity will always be to the right as our arrow goes to the right. The variable x, we want to keep our variables on the left side of the inequality because, as we notice, the pointer of our inequality acts like an arrow. It tells us more or less which direction our graph on our inequality will proceed. But the key is keeping your variable to the left. And that's the same in this case. We kept our variable to the left. We have a greater than or equal sign, 3. And then with the open circle, we do not include the 3, so we have a round parentheses. With closed circle, that's for the greater than or equal to. We have our square bracket. and then we include 3, comma, all the way up to infinity. Similar to solving equations, you use the properties of inequality, such as adding, subtracting, multiplying, or dividing both sides by whichever value. Again, similar to solving equations, properties of inequality act the same. However, the main difference between solving inequalities versus equations, when you multiply or divide by a negative, you need to change the direction of your inequality symbol. So we have 2 examples. First example, we subtract the 2, but then when we multiply by -2 to get rid of our fraction, we switch our inequality from a less than to a greater than. Similarly, when we divide by a negative, so for this example to the left, first add 6 to both sides, and then we divided both sides by -3. When you divide both sides by a negative, you switch the direction of the inequality. I also wanted to include this other example. We say 1 is less than 5, yet when we negate both the +1 when it becomes -1 and +5 when it becomes -5, you notice how -1 is greater than -5. So this is a similar idea because we multiplied or divided both sides by -1. So 1 divided by -1, -1. 5 divided by -1 is -5, yet -1 is greater than -5, unlike +1, which is less than +5. Here, we're talking about the transitive property. Basically, if A is greater than B, B is greater than C, then A is greater than C. Similarly, we had an algebraic expression, 3x minus 7 less than or equal to 5x plus 9. If 5x plus 9 is less than or equal to 19, then by the transitive property, 3x minus 7 has to be less than or equal to 19. Similar example, using numbers, if 1 is less than 2 and 2 is less than 3, then 1 has to be less than 3. We did this problem in class, so when we solve for an inequality, it's just like solving an equation. The key, isolate your variable. So step 1, we did our distribution. So we distributed the 3 to both the 2x and the 3 to the -5. That's how we have -6 minus 15 is less than 4x plus 17. Now, similar to an equation, once we get our variables to one side of the inequality, so we subtract 4x from both sides of the inequality. So 6x minus 4x is 2x. Bring down the -15, and then 4x minus 4x. In the end, this disappears, and you're just left with +17. So the +17 just comes on down for the ride. And then your next step, you will then subtract 15, you add 15 to both sides. So we wind up with 17 plus 15, which is 32. And then positive and -15 cancel out. So now we're left with 2x is less than 32. And then our last step, divide both sides by 2. And the result, x is less than 16. Now, set builder notation, this is relatively new. We use set builder notation as another way to describe an inequality. So for instance, given the previous problem, x is less than 16. You basically keep your algebraic expression The one really new thing is attaching your braces and attaching the X with your bar, vertical, up and down bar, and then you write X less than 16. And this is just a fancy version of saying X is less than 16. And you will see this probably more and more throughout the school year. So this is the equivalent of the set of all X such that X is less than 16. So I highlighted this second sentence along with this set builder notation expression, just so we are aware of the relationship between the two. We did a couple problems in class. So problem A, again, follow the rules for solving for equations, just like inequalities. So for problem A, we subtract 3 on both sides. And then the second part, we divide both sides by -5. Notice how it's in red. We have to switch our inequality. So in the end, rather than a greater than sign, it's a less than sign. Now, X is less than 6. Set up our number line. Notice how you have an open circle, arrow going to the left. Set up your number line appropriately. -6 is in the middle, and you have -5 on the right, and -7 on the left. Problem B. First step we did for this problem in class was subtract 2x on both sides. Good thing was, when we subtract 3x minus 2x, in the end we wound up with just a plain old x. And then, of course, your positive and negative 2x disappear. They go away. You bring down your positive 2. Now we were at the step x minus 8 greater than equal to 2. And then your last step, add 8 to both sides. And we wind up with x greater than or equal to 10. Notice how we have closed circle, arrow going to the right. Again, set up your number line correctly. That is key. This third problem we did in class, again, we started by subtracting 12 on both sides. Then our next step was we multiplied both sides of the inequality by the reciprocal of -2/3, which is -3/2. So what happened was the two fractions cancel each other out, but we still have to multiply -3/2 times +4, which we did it long way. If you have to write it out anytime you're in doubt, that's fine. 4 times -3 is -12. 1 times 2 is 2. And then we need to simplify -12 divided by 2, which results in -6. And again, switch the inequality. It was originally a greater than or equal. Now it's a less than or equal. And that will help you set up your graph. Again, -6 is in the middle. Negatives, -7, -8, and so on are to the left. -5, -4, and so on would be to the right. And your arrow goes to the left. And tonight you have 6 problems. That is your homework. You can try these. We will review at the beginning of class tomorrow. Thank you so much.